Hello everyone, in this video we are going to talk about rational and irrational numbers and what happens if you add or subtract two rational, or the combination of rational and irrational numbers. So we are working on IXL Algebra to H.3 Properties of operations on rational and irrational numbers. So, okay, so before I start solving these questions, I just want to show you kind of like a table that helps you determine what the answer is going to be. If you deal with two rational numbers, the answer is going to be rational. You might want to pause the video once I'm done with this and then write it down on the side to help you with these questions. So if you are adding a rational number and irrational number, the answer is totally going to be irrational. Okay? If you're mixing them together, the answer is irrational. If you're putting two rational as the first line, the answer is going to be the same kind. The confusing thing that you might end up with is when you deal with two irrational, the answer could be either one. That's the part that you might get confused when you solve these questions. The first one is easy. Here are some examples for the first one. Let's say rational numbers are numbers that you can write as a fraction, like 3, because you can write that as a fraction if you just put over 1, and then plus 3 over 2 plus 6 over 2. The answer is going to be 9 over 2. Add the numerators when the denominators are the same and keep that denominator the same. So 9 over 2, it's still as a fraction. It's still a fraction. So the answer is a rational number. Again, rational numbers are fractions, or numbers that you can express as a fraction. R equals any number that you can write as A over B. In this case, A and B are going to be integers. Integers are expressed with capital Z. You don't need to memorize that at all. I just wanted to write it down. Okay, let's move on to another example. 4 plus 1. The answer is 5. 4 is a rational number because you can always write it as 4 over 1 as a fraction. 1 is the same. You can write it as 1 over 1. 5 is, you can write it as 5 over 1. So when you add two rationals, the answer is always going to be rational. That's one thing that you might want to keep in mind. The second one is rational numbers. Just one example is for the second one. Let's change that color. Let's say we have 2 over 3 plus. Now the irrational numbers are numbers that you cannot write as a fraction. The most common reason for this is that the numbers are repeating. That's one reason. And the second reason is there is no pattern in the decimal portion. For example, E is an irrational number because E is 2. I think it is 74. Let's just look up what it is. It's the base of natural logarithm. Just want to Google it. Let's see if it is going to show us the value. Okay, the value of E. Okay, 2.718. And it goes on forever. It doesn't stop. I just saw that over here. Let's just, okay. This is the number. So when the numbers are not repeating with a particular pattern, you cannot write them as a fraction because you cannot predict what what the next digits are going to be. Yes, they are determined. We know what the next number, not us, like you and I, we don't know that, but it's known, like the next digit is known. So, but there's no pattern. Therefore, you cannot write it as a fraction, which is why it is called an irrational number, E. Or same thing with pi. Pi goes on forever, or even if it stops at one point, we don't know that yet. We couldn't find a number, a place value that the pi stops so far. So what that does, pi becomes an irrational number because you cannot write it as a fraction. Because like thinking about 3 over 2, when you divide those two numbers, 3 over 2, it equals to 1.5. You see that it stops. Like 5 doesn't go on forever. Or 6 over 2, it's just 3. It doesn't go on forever. There's no like random pattern after that 3. When those two things happens, first thing is when there's a random pattern. Second thing is it goes on forever. Even if the number is the same, if it goes on forever, like 1.3 repeating. Let me see. You can write that as a fraction. So basically, when the number goes on forever with random pattern, it's irrational because you cannot write it as a fraction. Now, all things aside, when you combine them together, a number that stops when you write it as a decimal, and the number that does not stop because there's a random pattern after the decimal point, the answer is always going to be an irrational number. You can just convert it into when you just add these two numbers, it's not going to give you a fraction. It is going to give you a decimal. Let's try it using Desmos. I am pretty sure that you are familiar with Desmos graphing calculator. Okay, let's see. And that could be a tool to confirm whether your answer is right or wrong. 2 over 3 plus e. There we go. Let's try to... Okay, it's not even an option. Let me show you another thing. 1 over 2 plus 6 over 7. You see it gives me a decimal, right? But then there is this button for me to convert it into a fraction because it is possible. So that means this is a rational number because it's a fraction. This is another fraction. And then the answer is always going to be a fraction. You can just test out as many examples as possible. You will always end up with a decimal probably first, but you will be able to convert it as a fraction. So with this in mind, when you combine a rational number with an irrational number, the answer is always going to be irrational. Okay? So last thing, when you put two irrational numbers together, that is the confusing part. I know you might think like the answer is always going to be irrational, but it won't. That's the tricky part. So here are some examples. Let's say we are adding e and pi. Both of these are irrational. Let's see what happens. E plus pi. Let's see if the answer is rational in this case or irrational. So e plus pi, e plus pi. By the way, on Desmos, if you just type p and I, it turns into the symbol. Just an easier way to type pi. And then that's my answer. Looks like it ends, right? But it doesn't. This is all you see on Desmos, but it doesn't end. It goes on forever. I know that because I cannot convert it into a fraction. There's no fraction button available on the left. So here's another option. So I know that that is an irrational answer. What about pi plus another pi? It looks like the decimal ends, but it doesn't. It goes on forever, and I cannot convert it into a fraction. Therefore, this is an irrational. What about e plus e? Same thing, no fraction. What about, okay, so this one here is irrational. We did pi plus pi. That was irrational. We did e plus e. That was irrational. So then what's the problem? They all look like they're irrational. So the issue is when the irrational number is cancelled out by another number, by another irrational number. Here's an example. So before we start to that, I just let's do another example over here. Let's talk about this. Let's just talk about 1 minus e. What do you think about this? This one here is rational because you can write it as 1 over 1, which is a fraction. E, I know that it is irrational. Let me just change this to regular r, and then this one is irrational. When you put them together, like the second line over here, right here, rational and irrational, when you add or subtract them, the answer is always going to be irrational. Let's just test this out. 1 minus e. So 1 minus e, you see that I cannot convert it into a fraction. That tells me that this number, the answer is irrational. So I know that this whole expression is irrational. Now, what if, since this whole thing is irrational, I'm going to show you how you can end up with a rational number when you add two irrational. Because you can consider this whole thing, I put it in the parentheses, as one number now. It's just an irrational expression. What if I do this, plus e? I know that this is irrational too. So basically this one is irrational plus irrational. Just ignore these two. I know that the answer in the parentheses now is irrational, and I have another irrational. Add them together. Let's see what happens. Aren't these two going to cancel each other out? Like this e, positive, and plus negative e. They'll cancel each other out. The answer is going to be 1, and I know 1 is rational because I can write it as a fraction like this. So as you see, when the irrational expressions cancel each other out, the outcome could be rational. So let's just show you this, and I will show you another example as well. E plus, let me just take this out of the way, e plus 1 minus e. You see that it is 1, right? And since it's a whole number, there's no point of converting this into a fraction, but you know that 1 can be written as 1 over 1. It's kind of stupid for Desmos to put that fraction button over here and convert this into 1 over 1, but technically you know that 1 can be written as 1 over 1. Same thing applies to pi plus, if I want to get rid of this pi, it doesn't need to be 1 minus, it could be 5 or 55 minus. Now I want to cancel that pi out and put it over here. The answer is going to be 55, and you can just put over 1. It'll turn into a fraction. So the outcome of this whole thing, even though there was like this one was irrational, this one was irrational, the outcome could be rational. Now, you might want to pause the video and then write these down to use it as your notes to answer these questions. Now let's get started. After the instructions about the assignment, it's going to take like probably 2 minutes. E is the base, y is rational. So I know this is irrational, this is rational. When you combine them together, it says e minus y. Add or subtract, doesn't matter. Combining them together is going to give you irrational. So that's going to be the answer. When you mix them together, that's going to be the answer. So second example. Decide what b minus square root of 14. I know that this is rational. And square root of 14, unless they are perfect squares, like square root of 4, square root of 9, 16, 25, where you can take out as a whole number so that you can write them as a fraction. They are irrational. If you can do this, like square root of 4, 9, 16, or 25, they are rational, but in any other case, they are going to be irrational. You can test it out by putting it on Desmos and see that if you can convert it into a fraction. Now we are mixing them together, so the answer is going to be that one. Okay? Moving on to the next one. This one is irrational, square root of 17. It's not a perfect square. Let's see what this one is. That's irrational. So I have irrational, irrational. It could be anything. It really could be anything. Can be rational or irrational depending on the value of v. If v lets me cancel this square root of 17 out, then the answer is going to be rational. If it doesn't, then the answer is going to be irrational. But either way, it could be both. So we have a rational number over here. That's rational. Rational. The answer is rational. Okay. Rational. V is rational. So I have two rational numbers multiplied. The answer is going to be rational. 9 is rational. All whole numbers are rational numbers. D is rational. So same kind. They're both rational. The answer is the same kind. U is rational. 5 is rational. We have two rational numbers. The answer is going to be the same. So that's it. Let's do one more. S is irrational. This one is irrational. You have two irrational. Depending on the value, they can either cancel each other out, the square root ones, or not. So the answer could be either one. So yeah, that's it for this assignment, guys. Thanks for watching. Let me know if you have any questions. And we worked on IXL H.3 Algebra 2 properties of operations on rational and irrational numbers. We learned what happens when we combine them. We learned how to classify the outcomes when we combine two rational or irrational numbers. Thanks for watching again, and I will see you in another video.